Alright, so in this video, I'm going to be solving the equation 8 to the power of x is equal to 80. So, my only variable in this equation is x, so that's what I'm going to be solving for. And now for my solution. I'm going to rewrite my equation here. 8 to the power of x is equal to 80. And now, my first step to solving this problem is rewriting 80 as 8 times 10. So now I get 8 to the power of x is equal to 8 times 10. And now I can go ahead and divide both sides by 8. So then these two cancel out, and I get 8 to the power of x over 8 is equal to, all that's left here is 10. Now, if I have something in the form a to the power of m over a to the power of n, this is equal to a to the power of m minus n. So a to the power of x over 8, well, 8 is the same thing as a to the power of 1. And a to the power of x over a to the power of 1, by using this property, is going to equal a to the power of x minus 1. And this is equal to 10. Now from here, I'm going to take the log on both sides. So I get log of 8 to the power of x minus 1 is equal to log of 10. And the reason I take the log on both sides is because now I can use the property that states that if I have something in the form log a to the power of b, I can move this exponent b to the front, so it's going to equal b times log a. So log a to the power of x minus 1, I can move x minus 1 to the front, and I get x minus 1 times log 8 is equal to log 10. And this property is really important because before, x was an exponent, and it's really hard to solve an exponential equation, but now we moved x, and now it's a real term, and it's much simpler to solve. So now what I'm going to do is distribute my log x here. So now I get x times log x, or log 8, which is equal to x times log 8, minus 1 times log 8, which is just log 8, is equal to log 10. And now I'm going to add log 8 on both sides. So then these two cancel out, and I get x times log 8 is equal to log 10 plus log 8. And now we want to isolate x. So what I'm going to do is get rid of this log 8 by dividing both sides by log 8. So then these two cancel out, and I'll be left with x is equal to log 10 plus log 8 over log 8. Now log 10, that's equal to 1, if you guys already know. So I get x is equal to 1 plus log 8 over log 8. Now, this is the same thing as 1 over log 8 plus log 8 over log 8. And log 8 and log 8, these two cancel out, so I'm left with x is equal to 1 over log 8 plus 1. And log 8 is equal to 0.9031. So I get x is equal to 1 over 0.9031 plus 1. And 1 over 0.9031 is equal to 1.1073, and this plus 1 is equal to 2.1073. So this is my answer. Alright, so in this video, I'm going to solve the problem 500 squared minus 499 squared. So, to solve this, what I'm first going to do is rewrite this as 499 plus 1 squared minus 499 squared. And if I have something in the form a plus b squared, this is equal to a squared plus 2ab plus b squared. So 499 plus 1 squared is turned into 499 squared plus 2 times 499 times 1 plus 1 squared, and I have this minus 499 squared. Now, I can cancel out 499 squared and negative 499 squared, so I'll be left with 2 times 499 times 1 plus 1 squared. 2 times 499 is 998, times 1 is just 998, and I have this plus 1 squared, which is plus 1, and this is equal to 999. Now, I actually have another method of solving this. So I have 500 squared minus 499 squared, and this time I'm going to rewrite this as 500 squared minus 500 minus 1 squared. Now, if I have something in the form a minus b squared, this is equal to a minus b times a minus b, which is equal to, if I factor this out, a squared minus 2ab plus b squared. So this is going to turn into 500 squared minus 2 times 500 times 1 plus b squared, which is 1 squared. So these two cancel out. However, this is actually going to be in parentheses. So the negative sign distributes. So this turns into 500 squared minus 500 squared plus 2 times 500 times 1, which is the same thing as 2 times 500, minus 1 squared. Now these two can cancel out, so I get 1,000 minus 1, which is equal to 999. So again, I get 999 as my answer.